Hi guys, welcome to this session. I first of all want to target preparation of buffers. This question is coming from biochemistry, the first tutorial sheet, question 5. I want to target preparation of buffers. I want to see how we can work around the buffers. I want to see how we can prepare buffers. There was this question that is saying, describe how you prepare 5 liters of a zero point 0.3 molar citrate buffer with a pH of 4.47, starting with a 2 molar solution of citric acid and 2.5 molar potassium hydroxide. So I want to move step by step because I want you to have a better understanding on how you're supposed to go about the question and see how best we can assist one another. So first of all, I want to define a buffer, and I want to point out a few things that you're supposed to take note when you're trying to work out such kind of questions. So I'll keep it short and straightforward. So what I'll do is this. I hope I don't lose you along the journey as I try to prepare this buffer. So I want you I will just invite you in this session to follow me from one step to the next. So let's start. So how can you describe how to prepare a 5 liters of a zero point 0.3 molar citric buffer whose pH is 4.47, starting with a 2 molar solution of citric acid and 2.5 potassium hydroxide? So what I'll do is this. First of all, I want to point out something very important here. I want you to understand to say when talking about the citric acid, we are saying we have the HH equation, okay? So preparation of buffers. So I want first of all to bring in the HH equation. We have the HH equation that says pH is given by pKa plus the log of the conjugate base. In fact, we're talking about the concentrations of the conjugate base over the concentrations of the conjugate acid. Sorry. So over the concentrations of the weak acid, not the conjugate acid. So I'm talking about the conjugate base. So let me use a different color here so that you're able to see what I'm doing. So I'm talking about a conjugate base over a weak acid. And we know to say citric acid is a very weak acid. This comes from the fruits, the citrus fruits. It's a very weak acid. So this matches, it's in line with what we're doing here. So we're looking at the weak acid. Great. So this is the HH equation we're talking about. So it's trying to relate the pH to the pK of that citric acid plus the log of the conjugate plus the conjugate base over the weak acid. And then the other thing I also want to point out is this. I want us to gather the information that has been given here because the question is saying describe how you prepare 5 liters of a zero point 0.3 citrate buffer. So we're saying the conjugate base plus the acid is having a concentration of 0.3 molar. Okay? That's one thing I want you to know there. They're saying we have been given 0.3 molar. I want you to first of all see what is happening right now and the purpose of the zero point 0.3 and the purpose of the volume that has been given, which is 5 liters. So I'm trying to point out the point that the 0.3 molar or the concentration of 0.3 is for the citrate buffer. What does this citrate buffer mean? We're saying both the acid, remember if you want to write the pH, you can also write it as pH. I mean the HH equation can also be written as pH is equal to pKa plus log of what? The conjugate base can be written as that, and then the acid can be written as such. So that is the other way of trying to bring up the expression of the pH of the HH equation. I'm moving on. So much of my interest is in the zero point 0.3. So now to put my data in one place here, I'm saying both the acid, the HA, to represent the acid, and the acetation to represent the conjugate base as was being given as a total concentration of 0.3 molar. So I'm having a concentration of 0.3 molar right there. What else have I been given? The conjugate base plus the acid is having a volume of 5 liters. So for both that and that, we have a volume of what? Of 5 liters. Great. And then what else has been given here? We've been told to say the pH of the acid has been given as 4.47. So first of all, we also want to find out the pK of the citric acid. It is a standard value. It is always given there. And the pH, pK, a value of that citric acid you're going to get should be a value of 4.74. So it is 4.76. And then we've been told to say we are starting this buffer solution with a 2 molar solution of citric acid and 2.5 potassium hydroxide. So now the question that you must be asking yourself here is, what role is the potassium hydroxide playing in this chemical reaction? And what role is the citric acid playing in this chemical reaction? What role is it playing? And when you want to prepare a buffer, what is involved in that buffer? You need to have a conjugate base, you need to have a weak acid, you need to have the pK of that acid, and you need to have the pH. So we have been given the pH as 4.47. So let me point here so that you're able to see. We have been given the pH as 4.47, the pKa as 4.76. The conjugate base, we have it right there. We can make it as a subject of the formula. The weak acid, we have it right there. We can also make it as the subject of the formula. So I'm trying to find out the volumes at the end of the day, the initial volumes that we had of the conjugate base as well as the acid that we are reacting in order for us to prepare this buffer. That's what I'm trying to do. So now I'm going down that to see what I can do to find those values. So now I'm getting back to the HH equation. What am I supposed to do there? I proceed. So what is the pH? So I'll write it down so that I don't confuse you there. So the pH is pKa plus the log of the conjugate base right there over the acid. What acid are we talking about here? The citric acid. In fact, let me even put up the chemical reaction for it. Important note, our note there. I really don't want to make this video long because I just want to couple everything in one place so that you're able to comprehend what I'm talking about. But hopefully it won't be a long video. So what I'm trying to say here is the reaction that we're talking about here is the citric acid is C6H8O7. It is a reversible reaction giving us a conjugate base of C6H5O7, and then you have that there. Then plus the 3 hydrogen atoms, or the 3 ions, the hydrogen ions. So that is what we have here. I'll also label that this is our acid, which is acting as what? As HA. And the one that is acting as A, or the acetate ion, is this one here, which is the conjugate base. So this is our acid, this is the conjugate base. The denominator and the numerator, the denominator and the numerator in the HH equation. I'm trying to prepare a buffer. Hopefully I haven't lost you. So we're still moving, guys. We're still moving. Let's see what we can do now. So I'm still using the pH, the HH equation. What's the value of the pH? So I'm still coming here. I'm saying pH is equal to pKa plus the log of what? The log of the acetate ion, or the conjugate base, over the acid, the concentration of the acid. And then what's the pH that has been given in the question? We have been given a pH of 4.47. I'll put it there. A pH of 4.47. What's the pKa value? The pKa value of citric acid has been given as what? As 4.76. 4.76 plus log of what? Do we know the values of the acetate as well as the acid? We don't know the concentrations yet. So I'll put it there over the HA. Okay, so I'm going to say this is an equation as well, an incomplete equation, but I have to complete it. But before I complete it, I have to in fact not maybe, I have to substitute the concentrations of the acetate ion, which is right here, and also have to substitute the concentration of the acetic acid, the citric acid, which is right there. But where am I going to get these concentrations? I want you to note something very important. There's something that we are given in the introduction or in the question itself. We were taught to say the citrate buffer, and I said the citrate buffer, this right here, the citrate buffer is a combination of the acid as well as the conjugate base to give us a concentration of 0.3. So if I say the acetate base, the conjugate base, or the acetate ion, which is this one here, I give it a letter as Y. So I am trying to find out what that value is. So what I'll try to do is this. I'm still moving. I'll say we know that the HA plus the A, the acetate ion, we've been given a concentration of 0.3 molar. So here we have it. And I'll say, okay, let's say HA is being equated to a letter as Y. So to mean HA, in fact the acetate ion, I'm saying I'm equating the acetate ion to a letter known as Y. So to mean the HA is going to have an expression of 0.3 minus Y, because I'm trying to make HA the subject of the formula. Let me not confuse you. I'm saying, let me forward it direct there. What I'm trying to do, I'm trying to work with this equation right there. I'm trying to work with this equation. So if I say HA is equal to Y, I'll just do that. Let me come back right there. So I'll say the HA plus the A, the acetate ion right there, I'm saying it's equal to a Y, which is equal to 0.3. What is going to be HA? HA is going to be 0.3 minus Y, just like I was writing it right there. So now, in this equation, the HA and the acetate ion, which is the conjugate base on top and the acid, I'm going to replace the A, the acetate ion, which is right there, with the Y, and the acid, I'm going to replace that one with 0.3 minus Y. I still proceed. I'm getting back to the HH equation. Remember, I still have my pH and the pKa values. So what will happen there is, I'm going to have 4.47 is equal to 4.76 plus the log of what? Look at what is happening right there. On the conjugate base, the upper part right there, what do I have? I was saying I'm replacing that one with the Y. I don't know what value it is. And then on the acid, I'm saying I made it the subject to the formula. I'm going to have 0.3 minus the Y. I'm having that. So now I do have like terms here. There's 4.47 that can be subtracted from 4.76, so I can collect that. So I'm going to have 4.47 minus the 4.76, which is equal to the log of what? The log of, open brackets, Y over 0.3 minus Y. I'm still trying to prepare this buffer. So the procedure might seem long, but it's very beneficial and very easy. So let's just move at the same pace. I hope I've not lost you. If I have, just try to get back to the video and see how you can get the concepts. What is important here is for you to grasp the concept and see how you can use it to attempt a different question in the same manner. So I still have to find the difference here. I'm saying 4.47 minus 4.76. What value am I going to have? I'm going to get negative 0.29, which is equal to log of what? The log of Y over 0.3 minus y. What's the next thing? I have this equation right there, but I want to get rid of the log. And I know to say this is a natural log, and this natural log here has a base of 10. So to remove the log out of this, I'm just going to say the y over the 0.3 minus the y is going to be equal to the 10. Then you equate this. This becomes an exponent to the power negative 0.29. If you didn't get that procedure, there's something in math where you work at the rules of logarithms. So when you've been given a natural base such as log y, maybe that's saying equal to 2, they're telling to find the value of y there. Here, you know to say the natural base of this log is 10 if it's not shown. So you're just going to say y is equal to 2 to the power 10. Okay? I mean, it's equal to not 2 to the power 10, but 10 to the power 2. Right? So you just create what the subject there, and then you make the subject of this log as your exponent, so to the power 2. So that is how it works out. This is the same step I was trying to take right there. The log here is a natural log, which is a 10. So it's just 10 to the power negative 0.29. And that's how it works out. So I was just trying to explain a few things, then get back to mathematics. But let's soldier on. So after doing that, we're trying to find a value there. So after collecting like terms and finding out here, if you punch on your calculator 10 to the power negative 0.29, what value are you going to have? So let's proceed. I'm going to still have y over 0.3 minus y. We're going to have a value of what? My calculator is showing me 0.5, 1, 2, 8, 6, 1, 8, 4. Okay, so I'm trying to find the value of y. You know, this can just be over 1. Then what are we going to do here? We're going to cross multiply, and after doing that, the y goes there, and then the 0.03, the 0.3 minus y is going to cross multiply with everything there. Then the y is going to multiply with the 1. So y is equal to what? Then the y is equal to what? We're going to have that big number there, 0.51. The reason I've carried all the numbers, I would have just said 0.51, but just for the purpose of accuracy, I'm just trying to provide the best work. 2, 8, 6, 1, 8, 4, but we'll finish up quickly. This is 0.3 minus y. When you do that, you're going to have y being equal to what? So when you multiply this by 3, we are going to have a value of 0.15385454115. Then that value just minus 0.51286184y. So this y here and the other y there, those are like terms. So this can cross the equal sign and becomes a positive. So this y plus this has now moved from the positive to a negative because that's crossed the equal sign. So this becomes 0.51286184y being equal to 0.153854415. Okay, so this y plus that, this y is just a 1. So I'm just adding a 1 to everything there. And what am I going to have? I'm going to have something of this nature. I'm going to have 1.15 3 8 5 8 1 5y being equal to 0.153854415. So if you want, you can just round off to avoid complicating all these numbers right there. But just for the purpose of accuracy, I'm just trying to do that. But you must arrive at the same answer even when you round off. So I'm going to have 1.153858815 right there as well as 1.1538515. Hope I've not messed those numbers up. So this y is going to be equal to what? It is going to be equal to a value of 0.153858815. 0.1 molar. Okay, so now I just found out that my y, and the y was equal to what? The y was equal to the conjugate base. Good. So this y was equal to the conjugate base. The conjugate base. If I've not messed up the spelling, so that's the conjugate. There's a there. So that's the conjugate base. The 0.1 molar is the conjugate base. But how about the weak acid? What's the concentration? So remember, we had that one equation that was relating everything. So the HA was equal to what? The HA was equal to this. We said HA was equal to 0.3 minus the Y. What's the 0.3? 0.3 minus the Y is what? 0.1. So it means that this HA was equal to the weak acid, which is the citric acid. So the citric acid, which is the HA, is equal to what now? We're going to have 0.3 minus 0.1. I'm going to have 0.2 molar. So this becomes the concentration of the weak acid. And remember what I said initially. In the question, we were given this. This is our question. We were told to say the citrate buffer has a concentration of 0.3. So, and I told you to say the citrate buffer, when they are mentioning a citrate buffer, it is a combination of the conjugate base as well as the conjugate acid. The conjugate base as well as the weak acid. And what we found here is that the conjugate base has a concentration of 0.1, and the weak acid has a concentration of 0.2. And if I add 0.2 plus 0.1, we are getting a 0.3, which was the given value in the question. So this makes everything right. Wow, it's kind of good when you're in the exams and everything's just flowing, and yeah. So we're having the weak acid with a concentration of 0.2 and the conjugate base with the initial concentration of 0.1. So we just found out one thing. In trying to prepare this buffer, we have the conjugate base with a concentration of 0.1, and we have the weak acid with a concentration of 0.2. What else do we need? We need to find the volumes. So how are we going to get the volumes? So what I'm going to do is this. For us to get the volumes, I'll just change the color to yellow. So I'm trying to find now the volumes. I'll start with the acid. What's the molarity of the acid that we have found, or the concentration? The concentration of the acid that we found right now is 0. Is 0. The weak acid is 0.2. Weak acid concentration, we have found it as 0.2 molar. What can I get here? I can find that using the number of moles, because remember that in the question we have also been given the volume of both the conjugate acid as well as the conjugate base. So there's a sense in which in that 5 liters we have the weak acid as well as the conjugate base. So the volume right there is a volume of 5 liters that was given. So let's find out the what? Let's find out the number of moles. And we know to say concentration. I'll do it from here. Concentration is given by number of moles over the volume. I'm trying to find the number of moles. So to find the number of moles for this is just the concentration of 0.2 times the 5 liters, which is the volume. And I'm going to get how much? I'm just going to get 0.2 times 5. That's just 1 mole. 1 mole of what? Of the acid. Which acid are we talking about? The citric acid, the weak acid. So after finding 1 mole of the weak acid, how can we now get the volume? Remember that in the same question, we were given the what? We were given the concentration of the citrate buffer. The O buffer 0.3. Okay? So I'm going to say concentration again is given by number of moles over the volume. I'm trying to find out the volume of the weak acid that was present in the buffer. The O buffer, which was made up of the conjugate base as well as the acid, has a concentration of 0.3 molar. So in fact, there's no need for me to write the word molar. I can just do that, which is equal to the number of moles. What moles did we find for the weak acid? We found out the moles of the weak acid as 1 mole. So in this 1 mole of the weak acid, and then the O citrate buffer solution had a concentration of 0.3. What is my volume in there? So what are you supposed to do here? You just cross multiply. And when you do that, you're going to have 0.3V equal to 1. And when you divide by 0.3 there, divide by 0.3, the volume of the weak acid, is going to be 1 over 0.3. And 1 over 0.3 is going to give us 3. Let me change the color so you see. It's going to give us 3.3 liters of the weak acid. So I just found weak acid volume. How many things have I found for the weak acid? We found the initial concentrations of the weak acid, which was 0.2. What have we found else? We've also found the volume of the weak acid that was participating in the formation of this buffer as 3.3. So now let's find out the acetate ion or the conjugate base. The same step we're going to do here, because we already have the concentration that we found for the acetate buffer. So next we proceed to the next page. So what we're going to do here is that we know previously, if I get back right there, previously we found out that the conjugate base had a concentration of 0.1. So that 0.1, I'm going to multiply it by what? I'm going to multiply it by the number of liters for me to find out the number of moles. So I'm saying the conjugate base concentration that we just got is 0.1 molar. And then for the weak acid, we just found 0.2. So I'm trying to find out the number of moles. And then we know that the volume that we had was what? Was 5 liters. And I've just been trying to repeat and sing the same song to say the 5 liters is both for the weak acid as well as the conjugate base. So I'm trying to find the number of moles. Concentration is equal to the number of moles over the volume. What's the concentration? 0.1. Number of moles? I've got no idea. The volume? The 5 liters. And if I multiply 0.1 times 5, what am I going to have? 0.1 times 5, I'm going to have 0.5. So the N is equal to what? 0.5 moles. So after getting 0.5 moles, what am I supposed to get? I'm trying to find the volume. To find the volume of the conjugate base that was participating in the formation of this buffer, what are we going to do? We know that concentration also is equal to the number of moles over the volume. What are the moles I found? I just found the moles of this conjugate base as 0.5. As 0.5 right there. How about the volume? We don't know the volume. That's what we're trying to find. How about the concentration of the O acetate buffer? It was of the O citrate buffer, not acetate buffer. It was a citrate buffer because of the citric acid. So the O concentration of the citrate buffer was 0.3. So this was 0.3. Moles we found there is 0.5. The volume, we've got no idea. So we are trying to find that. So this is just over 1. You cross multiply the V by 0.3. We're going to get 0.3 V equal to 0.5. Then divide by 0.3. Then divide by 0.3. What volume are we going to get? So when we do that, we're going to get a volume of 0.5 over 0.3, and we're going to get 1.7 liters of what? Of the conjugate base. So look at the beauty about this question. What was the volume that we got for the weak acid? Let me take you back. We got the volume that we got for the weak acid. We got a volume of 3.3 liters. How about the volume of the conjugate base? We got the volume of the conjugate base as 1.7. So now remember that formula that we had. What we're saying, we're just playing with the weak acid plus the conjugate base while we're given 0.3. Let's find out if this is right. What was the weak acid, the volume of the weak acid that we just found? I mean, sorry. Um, the volume. No, this is the concentration. I've already proved for concentration. How about the volume? We're given to say it was equal to 5 liters. The weak acid that we've just found, the volume that we just got was 3.3 liters plus the 1.7 there liters. So if you add 3.3 liters of the weak acid plus the 1.7 liters of the conjugate base, you're just going to get 5 liters. So that is what it is. So everything is right there. The initial concentration of the weak acid that we had was 0.2. The conjugate base we just found as 0.1. 0.2 plus 0.1, we're going to get the total concentration that we're given in the question as 0.3. The volumes that we just found, 1.7 liters was for the conjugate base, and then the 3.3 liters was for the weak acid. 3.3 plus 1.7, we're going to get 5 liters. So everything is working with respect to our favor. So that is how you prepare this buffer. So in summary, you can now tell the examiner to say, in order for us to prepare this buffer, we need, so let me put that in red. In order for us to prepare this buffer, we need 0.1 molar of the 0.1 molar was for the conjugate base, 0.1 molar conjugate base of volume what? The conjugate base is having a volume of 1.7 liters, and we also need 0.2 molar of the weak acid. And the weak acid in question here is what? The citric acid. I'll do that. Of volume what? Of volume 3.3 liters. So this is how you prepare this buffer. So actually preparing buffers is something very easy. We were just looking for the volumes. We were just looking for the concentrations because we were working with respect to the HH equation. We're just trying to work along with the pH, the pKa values, the concentration of the conjugate base, as well as the concentration of the conjugate acid. So every time you've been taught to prepare a buffer, just look at the H equation. pH is equal to pKa plus log concentration of what? Of the conjugate base over the concentration of the what? Of the acid. So now I'll ask myself questions right there. Do I have the concentration of the conjugate base? Yes, I found it as what? As 0.1 as a conjugate base. Do I have the concentration of the weak acid right there in my question? Yes, I do have the concentration of the weak acid, which is equal to 0.2 right there. The conjugate base, 0.1. Do I have the volumes for me to get these concentrations? Yes, I do. 1.7 and 3.3. Do I have the pH? It was already given in the question as 4.47. Do I have the pK value? Yes, it was given as 4.76. So I have everything that I need for me to prepare the buffer. So guys, this is how you prepare the buffers. I wanted to make this very simple and straightforward. I hope I made a difference somehow. Thank you so much. I look forward to interacting with you in the next questions.